If you've ever seen a fire in a movie, you've probably seen this happen. A single sprinkler goes off, and suddenly every sprinkler in the building starts spraying water everywhere. It looks dramatic. It also isn't how real fire sprinkler systems work. In reality, most fires are controlled by just one or two sprinklers, not the entire building. So how does that actually work? How does a system know exactly where the fire is? How does it activate at the right moment? And how does water get there fast enough to stop a fire before it spreads? The answer is a carefully designed system hidden inside walls, ceilings, and mechanical rooms. And once you understand it, it's surprisingly simple. Let's start with the part everyone sees: the sprinkler head. At first glance, it doesn't look like much, a small metal fitting in the ceiling with a glass bulb or metal link inside. But that small component is what controls everything. Each sprinkler head is independent. That means it only activates when it detects heat at its specific location. Inside the head is a temperature-sensitive element, often a small glass bulb filled with liquid. When the air around it heats up to a specific temperature, usually around 155 degrees Fahrenheit or 68 degrees Celsius, the liquid expands and the glass breaks. That break opens the sprinkler, and only that sprinkler, not the others. This is one of the most important things to understand. Fire sprinklers do not react to smoke. They do not react to alarms. They react to heat. That means water is released only where the fire is actually hot enough to trigger it. Once the sprinkler opens, water flows immediately. But that water isn't coming from nowhere. It's already in the system. In the most common setup, called a wet pipe system, the pipes are always filled with pressurized water. So when a sprinkler opens, water is released instantly. There's no delay, no waiting, no activation signal needed, just pressure and flow. This is why wet pipe systems are so effective. They are simple, reliable, and fast. But not all buildings can use this type of system. In colder environments, water-filled pipes could freeze and burst. So instead, some buildings use what's called a dry pipe system. In this setup, the pipes are filled with pressurized air instead of water. When a sprinkler activates, the air pressure drops, which allows a valve to open and let water flow into the pipes. There's a slight delay compared to wet systems, but it prevents freezing. Other systems are even more specialized. Pre-action systems are used in places like data centers or museums. In these systems, water is held back until both a detection system and a sprinkler head activate. This reduces the risk of accidental water damage. Then there are deluge systems used in high-risk environments like chemical plants. In those systems, all sprinkler heads are open, and water is released across the entire area when triggered. But for most buildings, it comes back to the same idea: individual sprinkler heads responding to heat. Now let's talk about where the water actually comes from. Because spraying water is only useful if there's enough of it and enough pressure. In many buildings, sprinkler systems are connected directly to the city water supply. But that's not always enough. Large buildings often need additional support. This is where fire pumps come in. A fire pump increases water pressure to make sure it can reach every part of the building, especially upper floors. Some buildings also have dedicated water storage tanks. These tanks ensure there's a reliable supply, even if the main water system is disrupted. So when a sprinkler activates, it's not just releasing water, it's drawing from an entire system designed to deliver it quickly and consistently. And all of this happens automatically. No human input required. That's what makes the system so powerful. It doesn't wait for firefighters to arrive, it starts working immediately. And that early response makes a huge difference. Most fires grow rapidly in the first few minutes. If they're controlled early, damage is dramatically reduced. In fact, studies have shown that most fires controlled by sprinklers are stopped with just one or two heads, which brings us back to the biggest misconception. Sprinklers don't all go off at once. They respond individually. That precision is what makes them effective. Now, there's another important part of the system that most people never see: maintenance and testing. Fire sprinkler systems are not something you can install and forget. They need to be checked regularly. Valves must stay open, pipes must remain clear, sprinkler heads must not be blocked or damaged. If something goes wrong, the system might not work when it's needed. That's why inspections are required. Technicians perform flow tests, check pressure levels, and verify that all components are functioning correctly. This ensures the system is ready at all times, because when a fire happens, there's no room for error. And despite how simple the system looks, it is incredibly effective. Fire sprinklers have been shown to significantly reduce fire-related deaths and property damage. They don't eliminate fires completely, but they control them. They slow them down, they give people time to escape, and they give firefighters a much better starting point. That's why they are required in so many buildings today. Homes, offices, schools, hospitals, warehouses, all protected by a system most people rarely think about. And like many forms of hidden infrastructure, the better it works, the less you notice it. You walk through buildings every day without thinking about what's above you. But right above your head, there may be a network of pipes, valves, and sprinkler heads ready to respond instantly, waiting for a situation that hopefully never happens, but if it does, ready to act. That is how fire sprinkler systems actually work. A simple idea, executed with precision, and quietly protecting buildings and people every single day. If you enjoyed this video, make sure to like and subscribe to Hidden Infrastructure of the World. Also, comment down below what hidden infrastructure you want to see next. See you in the next video.